Let's open this non-trivial problem by noticing that 1 is a solution because the ceiling of any integer is the integer itself. And so this is equal to 1 to the 1, which is equal to 1. So we only wish it was that easy. It is a non-trivial problem, but this is one of the solutions. So far we have one solution, namely 1. Okay. Now, how about others? Now, let's take a careful look at the definition of the ceiling function. The ceiling function always returns an integer. So we're just going to have a bunch of piecewise monomials. Okay, and just a concrete example. What if we did minus 7 over 3? Okay, and we elevate that to the ceiling of minus 7 over 3. Okay. Now remember, the ceiling function always returns an integer. And in this case, that integer is going to be negative 2. Okay, because negative 2 is the least integer that's greater than minus 7/3. Okay, so what we get right here is minus 7/3 raised to the negative 2 power. Now you guys, you remember your properties of exponents. You can invert this thing, and so this would actually end up being 9 over 49. And you can see any other, this is certainly not equal to 1, and you can see that any other number in this interval would be some kind of fraction like this that couldn't possibly be equal to 1. Okay, so now this number actually came from the interval, what, minus 3 less than minus 7/3. Less than or equal to negative 2, right? And you can see that if you were choosing intervals to the left of this, like say from minus 4 to minus 3, from minus 5 to minus 4, and so on, you're never going to get 1. Okay, you're just going to get a monomial that's either a very small, it's going to be a negative number, or a small number, and it's going to be less than 1 in absolute value, right? So that's for everything, you know. But there is one interval that you have to take a look at that will satisfy this condition. If you consider all the numbers in the interval, let's do minus 1 less than or equal to x less than or equal to 0. Right? Now, what is the floor of any of these numbers? I mean, the ceiling, excuse me. The ceiling of any of these numbers in this interval is 1. I mean, excuse me, is 0, right? And so what does that tell us? That tells us that for any x in this interval, you would have x raised to the ceiling of x equal to 1. Isn't that cool? See, again, that's the famous, easy to prove, any base raised to the 0 power except for 0 itself is equal to 1, right? So you see, we've shown that elements, values in this interval, no matter what they are. In other words, we're saying something absurd like this. For example, minus 15 over 16. Minus 15 over 16 would be raised to the power of 0, right? Because minus 15 over 16 has a ceiling of 0. So this would be equal to 1. Okay? So in any other negative number is going to enjoy that property. So what we have is 1, then all the x's between minus 1 and 0. And we will rule out 0 itself because 0 raised to the 0 is undefined in algebra. It means something in calculus, okay, but it's undefined in algebra. Okay, and it follows quickly just from the definition of how you prove this rule right here. You would be dividing by 0 if you follow how this proof comes to pass. Okay, so the answer that I'm positing is the trivial answer 1, then all the values between -1 and 0. Okay, so there's an infinite number of solutions. One, and just a little bit of hand waving. If you're out further to the right, you're always going to have x raised to some power n, right? Okay, like in other words, for x greater than 1, you're always going to have a ceiling for x greater than, let's just say strictly greater than 1. I'm sorry, strictly greater than 1, n will always be equal to 2. Or be greater than or equal to 2, excuse me. Okay, and what I mean, I should be writing this a little more carefully. For x elevated to the ceiling of x, okay, this is always going to be greater than or equal to x. Well, it's always going to be greater than or equal to x to the n, where n is greater than or equal to 2. I'm not quite getting that out correctly, but you know what I mean. In other words, as long as x is greater than 1, okay, the ceiling was going to be 2 or greater. Okay, the ceiling of x is going to be 2 or greater, so you're going to have x raised to, I got it right, x greater than or equal to 2, or n is greater than or equal to 2. And there's no way that's ever going to have a solution equal to 1, okay? So again, the only solution that I'm getting here, folks, would be this circled piece right here. The singleton 1, then all of the real numbers between -1 and 0 is the solution to this.